Bismillahirrahmanirrahim. Today I'm going to present my assignment 1, software engineering. The title of my assignment 1 is analyzing logical structure. Decision tables define an example for a decision tables, give benefits of using it. So, without further ado, let's get started. So this is my presentation slides. So this is Habib Isadit. My matric number is B031810436. My title is Logical Structure Analysis alongside designing some examples of decision tables coupled with demonstrating benefits of using a decision tables. So this is my cover page for the PowerPoint slides. I am going to submit my assignment to our Madam Mashanun Bitne Osman. So let's proceed without further ado. First thing first, we will be looking at the learning objectives. The learning objectives of my documentations are, in this document, what we will discuss is the decision table types. We will also see and understand the processes within our decision table. Uh, for our scope, what we will see is that we will define the following scopes in our documentations. A. Process description tools for decision tables. For example, types of decision tables with related examples. We will look at conditions where the usage of decision tables are most suitable. We will see the standards for creating decision tables and why we need them. We will see in details. We will discuss the advantages and disadvantages of decision tables. We will dive deeper by looking at some real-world examples. We will see how good we are in our problem solving skills as far as decision tables are concerned. We will look at one problem solving example. Based on our study, we will use our analytical mind to ask questions. So that's how we designed our scopes. Next, what we will see is the processes within the table. But before we go into the processes, we will see clear definition of decision tables. Basically, decision tables will show a logical structure with all possible combinations and conditions resulting in actions. What we will consider? We will consider every possible outcome to ensure that we have actually overlooked nothing at all. We will look into every possible actions and take into account each one of those actions or outcomes. I mean actions and outcomes. So that's what decision table is. Uh, what we also need to learn is that we keep in mind that a decision table can have multiple possible outcomes. We will see the best way to describe a complex set of actions. So why do we need decision tables, and why is it important for us to create standard for making tables? So decision tables are used to describe conditions. It identifies possible decision alternatives. We have one decisions, but we will see and identify if we have any other alternative flow. We will see actions that are performed at each decision. We will describe those actions. Why do we need to create standard for making tables? It's because for our convenience. Why? Because we will be naming the condition and values for our better understanding. We will list all possible actions that can occur. So we will be in a very good position to take the right decision. We will list down all possible rules for our easier convenience. We will define actions for each rule. So that's how we describe each rule in terms of actions. So apparently helping us to make informed decision. Finally, this all together, if we sum up what we have discussed in the aforesaid points, this will help us simplify the table. So now let's look at the description of the processes that go on when inside of a decision table, or these processes happen has to be kept in mind while when we design a decision table. First thing first, what we need to be aware of that a decision table will consist of 4 quadrants, and these are the 4 quadrants: conditions, rules, actions, and action entries. Conditions: a list of all possible conditions that can arise within a process. Rules contain selectors which identify different combinations of the possible conditions. Actions: a list of possible actions that can occur within a process. Action entries: this is an indicator which select the best possible actions to be performed. After that, what we need to know furthermore about the process is that the number of conditions and rules are always related. Each condition has 2 possible values, and this is what we know about the decision table as far as the condition is concerned. Also, we need to keep in mind we can use this formula 2 to the power n, where n represents the number of conditions in our application. When we apply our decision table logic in real world problems, we can take the help of 2 to the power n formula. N always represents the number of conditions. What we should be aware of is that some rules are duplicates. However, this decision table will always help us to simplify a complex set of conditions. For example, if we have rules with 3 conditions, 1 or 2 of them may control the outcome. The other conditions don't matter, because so that condition we indicate as minus, and that means we didn't need to examine them. That means if condition 1 and 2 fail, the third condition doesn't need any necessity to be examined, because the third condition depends on condition 1 and condition 2. Now we will be discussing about the types of decision tables. One is limited entry decision tables, 2 mixed entry decision table, third is extended entry decision table. So limited entry decision tables, it contains binary selectors y and n and negative in the rules quadrant. For example, in the action entries, it contains only the action selector symbol x. X means that the outcome is accepted, the outcome is positive, or outcome is true. That is what x represents or will represent in our examples. Limited entry decision tables contains the binary selector 1 and n and minus in the rules quadrant. In this action entries quadrant, the indicators other than x will also appear. For example, we can see we have 3 cases here: scenario 1, scenario 2, scenario 3. Salaries, employees, salaries of the employee. For example, in first scenarios, we see the salary of the employee is false. Hours worked, that means he is not going to be paid. Hour works is greater than 40 hours, so it's true. So what is going to be outcome? Overtime rate. He will be paid according to the overtime rate. So in the second scenario, both conditions are false or no, then he will paid a regular, this employee is going to be paid a regular rate. In the third case, if he is a salaried employee, if he is paid on a regular basis, hours worked doesn't matter. He is paid on a regular basis. That means definitely he is working regularly. So whether he worked more than 40 hours or not doesn't matter. So he will be paid a regular rate. So this is an example of mixed entry decision table. Extended entry decision table. This is an example of extended entry decision table. Selector in the rules quadrants are no longer simply binary y or no. They make this specific values or range of values. For example, we have 4 cases here. In the first cases, if the credit card is already approved, we don't need to worry about the amount of quantity ordered. This is the first case. So in the first case, the credit card is not approved. So if the credit card is not approved, so we don't need to worry about the quantity ordered. So his order is going to be definitely rejected. What we were talking about is the second case. If the credit card is already approved, and then we need to consider the amount of quantity that he had ordered. It's between 0 to 24. So definitely he will be given a discount. Maybe if he order less than 25, so his discount is 0%, but his order is accepted here, so we denote acceptance as X. In the third scenario, he has his credit card approved and the quantity ordered is above 24, which is 25, between 25 to 55. So he will be given some discount based on these conditions, which is 5%, and his order is going to be accepted. So the acceptance order is going to be denoted as X. So the same goes with the scenario 4. His credit card has been approved and he ordered a quantity exceeding 55. So the amount of quantity ordered ranges between 55, 56 to 99. So he has been given more discount and his order has been accepted. So this is one example of extended entry decision table. So we will look at more examples, some of the real world examples of decision tables. In this example, the credit card manager waived the credit status requirement in certain situations. So let's look into the tables. So we have 8 cases here. If the credit card status is okay, product is in stock. If he is getting the credit card manager waiver, all these conditions are true. Why? Yes. So his order will be accepted definitely. So same is the case. We have given the same set of conditions in scenarios 2 as well. His credit card status is okay, product is in the stock, but if the product is in the stock, he did not get a waiver from the credit card manager. So his order will still be accepted because his credit card status is okay and the product in the status in the stock. In the third scenario, the credit card status is okay, but product is not in the stock. So we can see N here, and he did get a waiver from credit card manager, but since the product is not in the stock, logically his order will be rejected. So in this way we can look into scenarios 4, 5, 6, 7, 8. They have same logic applies to all these cases from 4 to 8. If we look at the second table, if the credit card status is okay, product is in the stock, then his order will automatically accept it. Doesn't matter whether the credit card manager gives the waiver or not, because condition 1 and 2 is already fulfilled. So whether he has he get the credit card manager waiver or not, his order is going to be accepted. The same is the case with scenario 2 and scenario 3. Product is not in the stock. If the product is not in the stock, no need for us to know whether his credit card status is okay. No need for us to know whether he is getting waiver from credit card manager. His order will be automatically rejected. The same logic applies to scenarios 4, 5, 6, 7, 8. Remaining scenarios will have the same logic being applied to them as in the case with scenario 1, 2, and 3. In the third table, if we look at the credit card status is okay, product is in stock, we don't need to know whether he got the waiver from the credit card manager or not. His order is accepted. So these are the examples. So this is a basic example for a credit card manager decision table. So this is a decision table for a credit card manager, a basic example. So we can look further examples. So this is one of the real world example that we use ATMs. It shows a business logic. So the dashes indicate the condition aren't reached as this part of the rule. It means these dashes means that these conditions are negligent. So we have 5 cases here. In cases 1, we have valid card. No, we don't have a valid card. So valid card is false. That means the card is invalid. So his action, what will be the action? The order will be rejected. Yes, true. So we do not need to look whether the pin is valid, whether he key in invalid pin 3 times, whether the balance is okay. We do not need to look into these things. In the second scenario, the credit card, valid card, yes, he has, which is true. But he did in the second scenario, he doesn't have a valid pin. He or she doesn't have a valid pin, and so here no or false. Invalid pin 3 times. So first time he key in invalid pin. So the action, he need to re-enter the pin again. So invalid pin 3 times. No, one of the time he got the pin correct. So that's why his invalid pin equal to 3 is false, because at least one time he got correct, because first time if he had entered wrong pin, so he will be asked to re-enter new pin. That's why he have Y here. The card was not rejected, so N or false, re-enter pin. So that's why he has Y here. So this will continue in the while loop until and unless he has the correct pin. So in the third scenario, for example, in the fifth scenario, when he has actually key in the correct pin after keying in the wrong pin, after inputting the wrong pin, when he has finally input the correct pin, his cache will be dispensed. That's what we have seen in the scenario 5. His card is valid, he has valid pin, invalid pin 3 times. No, at least one time he has correct balance. Yes, he has balance in the card, so his card will not be rejected. This is the final stage of our loop in the scenario 5. So his card was not rejected, and he was not, when he key in the right pin, his card was not rejected. He was not asked to re-enter the pin, because finally at the end of the loop, he entered the correct pin. He will it doesn't need to keep the card because the dispense cache is in process, and finally his cache was dispensed. This 5 case 5 is the final input for a loop, the final input where he actually entered the correct pin. This is the case 5 for our ATCM decision table. Advantages of decision table. Advantages of decision table are easily understood. Alternatives are shown side by side. Cause and effect relationship is shown, and it permits easier user validation. Possible to check that all combinations and conditions have been considered. And what are the disadvantages? Disadvantages of decision tables are it cannot express the complete sequence of operations to solve a problem. It may be difficult for a programmer to translate a decision table directly into a computer program because we are using the visuals. So it will at times become difficult for a programmer to convert that into a real programming language or set it in a logical flow within a computer program. So when there are two or more alternatives, decision table cannot list them all. After that, we also see that decision tables does not depict flow of logic for the solution to be a given problem. So these are few disadvantages of decision table. Problem solving. Now let's solve a real world problem. This is our problem. So let's see how it goes. A marketing company wishes to construct a decision table to decide how to treat clients according to 3 characteristics: gender, city, dweller, age group. A, under 30, B, between 30 and 60, C, over 60. The company has 4 products, W, X, Y, and Z, to test the market. Product W will appeal to female city dwellers. Product X will appeal to young females. Product Y will appeal to male middle-aged shoppers who do not live in cities. Product Z will appeal to all but older females. So let's solve this problem. So this is how we will be approaching to the solution of our problem. The process used to create decision tables is in the following. The first first, we need to identify conditions and their alternative values. There are 3 conditions: gender, city, dweller, age, and group. So if we put these 3 into tables on the upper left side, what will happen? Gender alternative values are F and M. City dwellers alternative values are Y and N. I mean yes or no, or true or false. Age group dwellers alternative values are ABC. Now we need to compute the maximal possible number of outcomes, which will be 2 into 2 into 3. So female and male, 1 and 2, Y and N. This is for another 2, and 3 for ABC. So if you multiply, it's like permutation. So if you multiply all of them, how many possible outcomes we will have? We will have 12 possible outcomes. So this is how we will be designing the table, and we will see the possible market product. Our market products are W, X, Y, or Z. So we will also need to put this in 4 rows in the lower left side. So in the second point, we have discussed that the label on each column will be increasing number from 1 to 12, corresponding to 12 rules. For example, the first column, rule 1, corresponds to F, Y, and A. Rule 2 corresponds to M, Y, and A, and so on and so forth. So that's how we will be designing our table, and this is how our table will look like. So this is our initial table. So we have 12 scenarios or 12 cases, as we have seen how we compute the total number of possible outcomes. So in cases 1, the person is female and his city is Y, his age is A. So he will be able to purchase from the market X. market W and market Y and market. He will not be able to purchase from market Y, but he will be able to purchase. She will be able to purchase from market W, market X, and market Z because she is a female in scenario 1. In scenario 2, this person is a male and he lives in city Y. And if this and his age is falls between his age is around A. So if these three conditions are met, this person will not be able to purchase from market Y, or he will not be able to purchase from market X. He will not be able to purchase from market W. But he will be able to purchase from market Z. This is the conditions. So we have seen that first three conditions. If you look at the scenario 3, this person is female, he lives in city N and his age is A, so he will not be able to purchase from market W. He will be able to purchase from market X and market Z only. He will not be able to purchase from market Y. If we look at the scenario 4, this person is female. Scenario 3, this person was female. So female, and he lives in city. No, she doesn't live in city, and her age is A. If we review the scenario 3, she will be able to purchase from market X and market Z only. She will not be able to purchase from market W and market Y. So based on these three conditions, this female can purchase from following markets. So based on these first three conditions, gender, city and age, person 4 or male person can purchase from market Z only. Based on first three conditions, which are gender, city and age, this person 5 or this female person, she will be able to purchase from market W and market Z only. She will not be able to purchase from market X and market Y. In scenario 6, this person is male and she will be able to purchase male, and she lives in city Y and her age is B. So his age, because person 6 is male, so he will be able to purchase from market Z only. He will not be able to purchase from market W, market X and market Y. So this is how our decision table works out, and this is our final decision table. If you look into our final decision table, this is how it looks like. Okay, so we can also say modify this table. If we modify our requirements, so we can derive this table into this. Again, we see based on gender, city and age, it will decide whether the person is able to purchase from market W, market X or market Z. So this is the final decision table for our previous table after modification. The modification conditions were given here in this description. So what we can conclude? We can therefore conclude that decision tables are concise visual representation for specifying which conditions to perform depending on a given conditions. It describes the decision table quadrants, which used to describe the conditions, identify possible decisions alternative, indicate which action should be performed, describe the actions. And that's how we conclude the whole thing as far as what we understand of our decision tables. Now the thinking part. Let's ask few questions. Is it true that decision tables can have various layouts in software engineering? Yes. If we refer to this references as given in the link, we will see, depending on the software engineering concepts, decision tables can have various layouts, and it depends on the developers or the engineers or the software engineering concepts which are going to develop. The developers will decide which kind of layout he will choose for his convenience or for his easier understanding. So it entirely depends on the developer of the program, the kind of layout he will be used to construct a decision table. So these are the reference I have used in my slides. So thank you very much, madam. Thanks for your patience for walking through the slide. Thank you very much, madam.